So one of the things I want to go over is some of the algebra and geometry rules that I know you've learned in your past, but maybe with just a quick refresher, we'll be able to get these. So the first one, let's take a look at some arcs and some angles. If you have a central angle, that's when the angle is touching the center of the circle, and this arc measures 100 degrees, then this angle right here is 100 degrees. They're equal. Okay, now this one right here, this is called inscribed. Inscribed means that the angle is touching, the vertex is on the circle. Okay, passing up the center. See how it got smaller? If the arc that it intercepts is 100, then this angle is 50. It's going to be half as much. Okay. The angle that we're talking about is here or here. Now, it's not touching the center. We've got an arc on the left called x. We've got an arc on the right, and they're not necessarily the same size. So is this angle the size x, or is it the size y? But those are vertical angles, so I know they're equal. So it's not x, it's not y. What we're going to do is we're going to average them. X plus y divided by 2. So it's not the little one, it's not the big one, it's going to be the average. That sounds about right. Now the angle here, if the angle's way outside, it's not the measure of this big arc, and it's not the measure of this little arc. It's kind of like this rule, but it can't be the same because now the angle's outside. So what we're going to do is subtract. Let's make sure we take the big one, x minus y divided by 2. Okay, now we're going to go ahead and take a look at some chords and some segments. So here I have a chord inside the circle, okay, and there's two pieces to it. There's the C part and the D part, and here's another one that's been chopped into A and B. The rule says if you take A times B, take the two pieces and multiply them together of one chord, then that equals C times D. You can go ahead and multiply them. If you've got these things, these are called secants. A secant is a line touching the circle 2 times. So it's got part of a chord, and then there's a segment sticking out. Okay, so this is what you do. You take the part that sticks out. Part that sticks out times the whole thing. The whole thing there would be A plus B equals part that sticks out, D, times C plus D. Okay, part that sticks out times the whole equals part that sticks out times the whole. Okay, here's one. If you have a radius and it's perpendicular to a chord, okay, then what happens, these are radii here. Okay, you've got radius equal radius here. And then what happens is that chord has also been chopped in half. So then you've got half and half. So you could do some Pythagorean theorem or some angle work there. Here's a nice rule. If you have a diameter, since going through the center, okay, this is an inscribed angle. So this angle is going to be half of the arc that it intercepts. Or in other words, some people just remember when you have a diameter, then that angle or this triangle is going to be a right angle. Okay, that's just a rule. Here's one we've seen recently. If the radius goes right there and touches to a tangent. So a tangent is a line that intersects the circle once. If it's a radius and a tangent, then it's perpendicular. You've probably done a lot of problems like this in geometry where you then had a triangle. You did a lot of Pythagorean theorem problems in that chapter. This is called a sector. Okay, the area of the sector is theta out of 360 times pi r squared. Okay, but this is the arc length, so it's very similar. The angle out of 360, and then the circumference is 2 pi r. So if you need length or circumference, you do 2 pi r. If you need area, you do pi r squared. Here is an interesting thing. I found this in an ACT prep book, and they kind of described all the different ways two things can intersect. So really, all I want you to do is to look at this and study a circle intersecting a parabola. It could be like this, not touching at all. It could intersect in 2 points. It can intersect at most 4 points, or maybe just 1, 2, 3 points, or just 1 point. So there's all the options. Sometimes just seeing this once, you can visualize all your options, and then you can answer the question like that. The ellipse can be outside the hyperbola. It could be tangent like that, touching twice, 1, 2, 3, 4 times at most, or maybe one tangent and then these two intersecting, or just one tangent. Okay, a circle and an ellipse can be like this. 0, 1, 2, 3, 4. Or a line with the hyperbola, not touching at all, maybe touching once, or maybe touching twice. Okay, just kind of look at that a little bit. The next thing that we're going to study here are all the polygon rules. Okay, just refreshing your memory so you have those rules. The sum of the interior angles. The sum of the interior angles is n minus 2 times 180. And n is the number of sides. N is number of sides, or you could say number of angles because it's the same. The sum of the exterior angles outside, this is real easy. The sum, it's not even a formula, is always 360. Yeah, no matter what the shape is. You've got 1, 2, 3, 4, 5 sides. You take all the exteriors. So take this side, extend it, take this side, and then you just go around. 1, 2, 3, 4. All those angles outside is 360. If they tell you the shape is regular, that means all the sides, all the angles are equal, then you could find each one. So here's a definition for you. Regular means sides are equal and angles are equal. So then you could just divide it up. Okay, you could find all the interiors, and if it's regular, you can divide it up to find each. The number of diagonals formula, this one's a little trickier. It's n times n minus 3, and then divided by 2. You got 2 n's, you got a minus n, you got 3 to 2. For example, take this shape right here. 1, 2, 3, 4 sides. If n is 4, how many diagonals are you going to have? 4 times 1 divided by 2. Really? Just 2 diagonals? Yep. 1, 2. There's the 2 diagonals. Okay, so sometimes writing on the formula and testing it on a small shape just to make sure you've got the right formula is a good idea. Okay, you probably did an entire chapter in geometry on parallel lines. This thing right here, this is called the transversal. The transversal intersecting parallel lines. So make sure it says parallel or you see some sort of markings, then lots of cool things happen. Okay, vertical angles. Vertical angles are congruent. Let's see if we can find a pair of vertical angles. For example, 1 is vertical with 4. Vertical means right across, sharing a vertex right there. So, for example, 1 and 4. How about corresponding angles? Corresponding angles are angles that are like in the same place. So 1 is in the top left corner of this set. 1 corresponds with 5. Top left, top left. Those are also congruent. Now there's lots more sets. 2 goes with 6 and 4 goes with 8. We're just writing down one example here. How about alternate interior? Now you got to be interior. So you're only allowed to look inside the lines, but you have to alternate. Those are also congruent. For example, 4 and 5. 4 and 5. So since 4 is equal to 5, and 1 is equal to 4, and 5 is equal to 8, all 4 of those are actually the same size. So all 4 of those angles are the same size, and then 2, 3, 6, 7 are all the same size, if the lines are parallel. How about alternate exterior? Now you're only allowed to look outside the lines. Those are also going to be congruent. They're congruent. So 1 is alternate exterior with 8. Okay. You're still alternate exterior, even if your lines are not parallel. It's just that they won't be have equal measure. Now, I'm going to go ahead and draw a little line here because this one is different. This one's different. Same side interior. They're not congruent. Same side interior. So you look inside, interior, but you have to be on the same side, like 4 and 6. 4 and 6 are same side interior, but they're not congruent. Those ones are supplementary. And supplementary means that they equal to 180. So it's like the corners of a parallelogram. Same side interior are supplementary. Okay, just try to remember that. Everyone else is congruent. This is kind of a cool problem. I know you've done this last year in geometry class. Okay, if the lines are parallel, so let's put some markings here. Okay, if they're parallel, what you do, let's zoom in here a little bit, is you draw a third parallel line going right through that vertex. Now I know my job is to find x, but we're going to do some parallel lines, all three parallel. Now if we only look at these two parallel lines, 26 is alternate interior with this one right here. So that one's 26 degrees. Okay, now look at these bottom two. Since these are alternate interiors, it's a very bad picture because it doesn't even look like 100, but not drawn to scale, okay? 100 degrees there goes with 100 degrees here, so that one is 100 degrees. So that means that the measure of angle x is 126 degrees. Okay, I said it wasn't drawn to scale. I made up a bad number there. Okay, so that sometimes appears. That's a good problem. That's just asking if you know about parallel lines and some of these angle rules. Here's a bunch of formulas. I've already written them all out for you, so what I want you to do here is study them and try to look and memorize some of the rules. If you are a cylinder, for all of these shapes, what you do for volume is you take the area of the bottom, okay, then you times by height. So the area of this bottom here is pi r squared. Then you bring it up that much, and that's how much space is inside the circle, and then it goes up, 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 up. That's how much volume. Okay, same thing here. If you take the length times the width, if you take the bottom, and then you go up, 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 all the way that high, that's length times width times height. Now, surface area formulas are a little trickier because you have to do all 6 surfaces. This is a huge rectangle plus the 2 top and bottom circles. If they give you a weird looking shape like this is just asking you about your knowledge. Okay, so how would you find the volume of a blobby shape? Well, first, you have to take the area of the bottom, and they'll usually give you that number. Then you multiply by height, which is right here. But whenever something comes to a tippy point, that magic number 1/3. Whenever something is shaved off, so what that means is all the area here and here, that's 2/3, and the volume that's left is 1/3. Same thing here. The cylinder is just like the cone, pi r squared h, except when it comes to a tippy point, then you've got 1/3. Same thing here. This is kind of like a box, but when it comes to a point and turns into a pyramid like that, then it's 1/3. Okay. The volume is 4/3 pi r cubed. I always remember that the 3 goes with the cubed, but surface area is just 4 pi r squared. You get those 3's out of there. Okay, so make sure you memorize these formulas so you know what to do, especially the weird shaped ones, because that way they can test your knowledge without actually having a formula or a program. Let's just go back up here for a second. Whenever you're doing word problems and they say the supplement is always going to be 180 minus x if you need to write an algebraic expression. And whenever they say complement, then you're going to say 90 minus x. The complement of an angle is. You could represent it like that. Don't forget, you could also use the answers and kind of fill it in to the words they say and see which ones make sense. Okay, what are some other things? We're going to do a chapter on sequences and series, but we haven't gotten to it yet, so let's just give you what you need to get by. Okay, whenever they say arithmetic, that means to add d. To add d. And whenever they say geometric means to multiply, and they always use an r. Okay, for example, you have an a. Then the next term is going to be the a thing plus a d. Then the next term would be the a plus 2d's, and then a plus 3d's, dot, dot, dot. So that's an arithmetic sequence. Let me show you an example. What if it has 2, then 9, then 16, dot, dot, dot? Okay, so looking at this, what's the d that they keep adding? That's right, 7. Okay, it also could be subtract, which means your d would be a negative number since it's going down. Let's talk about geometric. So you take your first term, which is a. Then to get to the next one, it's a times r. Okay, then get to the next one, it's a times r, which is r squared. and then a times r cubed. Okay, so the idea here is multiply by r. For example, let's do one with numbers. What if we have 27? Then we have 9. Then we have 3. Okay, if you get the idea, tell me the next one. 1. Keep going. 1/3. Okay, so that means that the r must be 1/3. Okay, if you can kind of see patterns and stuff, that'll be enough to get through the sequence and series question on ACT. Here's a trick that I want to show you in case you have to do something like this. There are fancy formulas for summing things up, but if you know the trick, then you don't have to know that formula, and this will be enough to get the job done. Okay, so take a look at this. You have to add the numbers from 1 to 80. What you want to do is pair them up. Put the smallest with the biggest. So what's 1 plus 80? That's 81. How about the second smallest with the second largest? What's 2 plus 79? Also 81. Okay, 3 plus 78. Also 81. So what's going on here? Every time you pair them up, it makes 81. And how many sets of 81 are there? From 1 to 80. There's not 80 sets. How many sets are there going to be when you pair them up? 40. So if you take 81 times 40, drop the 0, 4 times 1, 4, 32. That means that the sum of the numbers is 3,240. Okay, so that's kind of a trick. There's a fancy formula that does exactly that. Now, what if it ended at 81? Okay, so what some people do is they cover up the next number. They do this with an even number of terms, and they take that one leftover number and they just add it on. If your numbers don't pair up evenly, just cover up your last one and do that. Okay, got it? Factorials. It doesn't mean excited math. Okay, so factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And we're going to divide by 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. Now, you don't have to pick up a calculator and push all these buttons. In fact, I'd rather that you didn't. This is a question of, do you know factorials and how to cancel? The 1 with the 1, the 2 with the 2, and the 3 with the 3. And you can cancel all these things out. So all you have to know is what 8 times 7 is, and that's 56. Okay. Now let me also show you where the factorial button is in your calculator. So if you turn your calculator on, okay, we're going to do 8 factorial. So what you need to push is the math button. Okay, and we're going to go all the way over here to probability. I'm just going to hit left and get there quickly. And there it is, number 4, 8 factorial. But then I'm going to divide that by 6. Hit math, go over there, factorial. And you could do it like that. Now, ACT knows you have these calculators, so they're probably going to ask you the question a little more like this, with letters. So now your programs and your calculator don't help you at all. So let's do some thinking here. I know factorial means multiply, and you go all the way down to 1. So n plus 2 would be the first number. And what's a little bit less than n plus 2? Well, it would be n plus 1. And what's a little bit less than that? N. And if I say n factorial, that means n and all the numbers under him till I get to 1. Do you know why I stopped with n factorial? Because n and all the numbers less than him can cancel with n and all the numbers less than him. This is a whole bunch of numbers canceling with a whole bunch of numbers. And so all you would have here is n plus 2 times n plus 1. Or you might have to multiply it out depending on how the answers looked. Okay, so make sure you know what factorial means and be prepared for a problem with letters. Okay, here's a couple of things here. I'm going to show you this button in your calculator in case you need to do probability. But let me tell you what this means, okay? This is the combinatorics, okay? And this means order does not matter. Order doesn't matter. I need 3 of you people to go help me carry some heavy boxes. I pick person 1, 2, 3. Does it really matter that I picked person 1 and then person 2? No, you're all going to get a heavy box. Okay. P, this is like permutations. This means that the order matters. The order matters. For example, the first person I pick gets to be the president, and the second person I pick gets to be the vice president, and the third person, that person gets to be the box carrier. Okay, this person gets $100,000. This one gets $1,000. Now one has to be the box carrier. Makes no money. So does it matter if I pick Susie, then Tony, and then Tom? Or Tom and then Susie and Tony? It matters, the order. So out of everyone, not only do I pick 3, but then amongst those 3, there's another permutation that happens. Okay, so if you need to do 24, choose 3. Okay, the first thing to do is pick, right there, or type 24. And we're going to hit math and go back to that probability command, and there it is, choose. So there's 24 students, and 3 of you have to help me carry boxes. There's 2,024 ways I can pick 3 box carriers. Now, this one here is going to be a lot more, because not only do I pick 3 people, but then the order in which that happens is going to play out. So 24, math, over to probability, and choose P. Oh, look at that. That's 12,144 ways. Because not only did I choose 3 people, but then the order in which I choose them matters. Okay. Let's just talk about sets a little bit. Sometimes this happens, and I don't know if you've seen this ever. This symbol right here is pointing up, and then there's this symbol pointing down. I always know the one that looks like a U means union. But the one that's like this one, that's not a U. That's almost like an I. That's intersection. Intersection. So visually, you've got set A intersecting set B. So what do they have in common? Intersect. Intersect. That means what do they both have? What do they both have? Okay, person A has a fluffy couch. Person B has a fluffy couch. They both have fluffy couches. But then this person has like a tall table. This person has a short table, something like that. Union means you put it all together. Okay, and union, that means kind of like when you unite in the ceremony of marriage. Person A takes all their stuff, person B, and you put it all together. Now you've got all the A stuff and all the B stuff, even if they had something in common. Now they got duplicates. A needs to unite with B intersect C. Okay, so to do this, the first thing we need to do is draw 3 sets of circles. So this circle here is going to represent all the A things. This set here, this circle here, is all the B things, all the elements in set B, and then set C. So you have to make sure that you overlap them as much as possible to show all the combinations. So what you need to do, first of all, is find the intersection of B and C. So what does B intersect C have? You have to shade the part that they both are touching. So the B intersects C, that's this stuff right here. B intersect C. But now we're going to unite that with A. So not only is all of this included, but now we have to grab all the stuff that A has. All the stuff that A has. Okay, and so this would be a visual of what the B intersect C added to the A part would look like. Okay, maybe you've seen some of the stuff, maybe you haven't, but hopefully this helps you get a couple more questions right in ACT. Thanks.